Hey, geometry class, we're moving on in the unit of polygons. We're almost done, really. And we're going to do kind of a piggyback lesson from the previous one where we talked about rhombuses, rectangles, and squares. And we're going to talk about conditions for rhombus, rectangles, and squares. Very, very similar to what we've covered before. But it all has to do with still understanding some key concepts that what we covered, and really understanding the whole development of quadrilaterals. So remember, we have all these quadrilaterals that we had to know about, and so we're gonna finish really talking about what's going on with rhombus, rectangles, and squares, and then finally we can get into trapezoids and kites later. But we'll wrap that up. So what we'll talk about today is identifying the rhombus, rectangle, and square, and then what properties they have. And we're going to recall briefly some definitions where we talked about a rhombus, just a parallelogram with 4 congruent sides, a rectangle, parallelogram with 4 right angles, and then that awesome square. Because it's awesome, it's a square, it's a rhombus and a rectangle. Awesome! So we're going to go over that and then do some examples of problems. We'll do some problem solving and have fun along the way, because yay, math. So a couple more notes about rhombus. Again, this is what we covered briefly in the previous lesson, but some more details to it. So we're talking about this first note. We're making a condition to determine if there is a rhombus. So if we have a parallelogram, that's the key there. We can't overlook that. If we have a parallelogram and the diagonals are perpendicular, if it's a parallelogram and the diagonals are perpendicular, we get a rhombus. And if it is a parallelogram and the diagonals bisect opposite angles, we have a rhombus. Okay, so we have to remember some of the stuff we had talked about in the previous lesson, but now we're just going backwards. The key thing is to inform ourselves that we're dealing with parallelograms that do this. So when we get into other stuff later, it's not always a parallelogram that have these properties, but in this case, it has to be a parallelogram. The other note is for the rectangle. Again, if we have a parallelogram, and the diagonals are congruent, then we have a rectangle. Excuse me. So we have to remember that we're talking about parallelograms. Let's do some work. Yay. All right, so here's an example of a question. Can we conclude that the parallelogram in the given example, is it a rhombus, a rectangle, or a square? And what we're going to do is explain. So what do we know? We know that we're dealing with parallelograms. Okay, so that brings in a whole lot of stuff, that's congruent to that, and that's congruent to that, right? And so we know what's going on. Can we conclude that this is a rhombus, a rectangle, or a square? Now, what's happening in this given thing? We have a diagonal that is bisecting opposite angles. Okay, it's bisecting angles. And if we have a parallelogram and we have diagonals that are bisecting opposite angles, that note that we just saw, we have a rhombus by definition. So indeed, that is a rhombus. Now, how is that true? Remember a good old triangle congruence, I hope you know. We have angle, side, angle, triangle congruence. So that means all of the sides are congruent. What's even cool about that, since these two angles are congruent to each other, it's an isosceles triangle, right? Oh my gosh, Mr. Katz! So it's isosceles triangle, so that's congruent. Oh man, so many beautiful things are happening. So we know this is going on, therefore this is indeed a rhombus. We have 4 congruent sides. Okay, that's angle, side, angle. You'll see that again in another question. Ruin it. What about this next diagram? So here's another diagram. Is it a rhombus, a rectangle, or a square? Explain. Oh my gosh. And if I hear anybody say this, it looks like one, holy cow, I'm going to lose my mind. Remember what we know. Don't judge anything by how it looks. Don't ever say because it looks like one. Okay? So is this a rhombus, a rectangle, or a square? Well, it's a square because it looks like one. No. Don't ever say that. We have to establish what's going on. So what's going on here? We have diagonals that are bisecting each other. Okay, so we know that's a parallelogram. I mean, it's given it's a parallelogram. So parallelogram diagonals bisecting each other. What's cool about the diagonals, though, check it out. The diagonals are congruent to each other. Okay, isn't that neat? Diagonals are congruent to each other. Now, what does that mean? What do we know? We know this. If the diagonals are congruent to each other, we have a rectangle. Check it out. If we have a parallelogram and the diagonals are congruent, we have a rectangle. Okay, so we know we're dealing with a rectangle here. But wait, there's more. Okay, so we know we have a rectangle, but something else. But something else. What's happening here? Here we have a 90-degree angle. We also have diagonals that are perpendicular. Ooh. And what do we know about diagonals that are perpendicular? We know we have a rhombus on our hands. Okay, so if we have diagonals that are perpendicular, we have a rhombus as well. So not only is this a rectangle, this is a rhombus. Yo! What does that mean? So what does that mean? If it's a rhombus, what does that mean? What defines a rhombus? A rhombus has 4 congruent sides. So what do we know? We know that all 4 sides are congruent. Boom, 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 boom. So it's a rectangle with 4 congruent sides. You now know as well as I do that we can conclude that this is indeed a square. Yeah, the square. Remember, it's both a rhombus and a rectangle. Isn't that cool? So we can conclude that this is a square. Why? Not because it looks like one. Goofballs, smack. I'm going to smack that argument out of your head. Not because it looked like one, because we can prove that it is. Okay, the diagonals are congruent, rectangle, 90-degree perpendicular intersecting diagonals, rhombus, rectangle and rhombus, square. Okay? Okay. Now, next question. A parallelogram. Parallelogram. Key term here. All the things we know about parallelograms. A parallelogram has angle measures of 20, 160, 20, 160. Can we conclude that it's a rhombus, a rectangle, or a square? Let's explain. Okay. Let's entertain a few notions. Let's just draw a random parallelogram. It's random because it's a random parallelogram. And it has angle measures of 20, that's 20, 160, 20, 160. Okay. So is this a parallelogram? Okay, yeah. Is this a rhombus, a rectangle, or a square? Explain. Well, what do we know? We know this is a possible thing because we have opposite angles are congruent, and we have consecutive angles that are supplementary. So far, so good. Is there anything else we can conclude about it? Well, can we write it in another way? Well, is it possible for us to write this? Is it possible to write that this shape or this thing has 20, 20, 160, 160? Is that possible? No. No, that's not possible. Okay, so because those aren't congruent. So that's not a parallelogram, right? Opposite angles would not be congruent. That place is not a parallelogram. So we know we can't entertain it that way. It has to be entertained this way. So can we conclude that this is a rhombus, a rectangle, or a square? Well, let me ask you this. What if I exaggerate this shape and just go crazy, wow, and do that? Will it change the angle measures? Right? Will it change the angle measures? So I'm still dealing with 160 here and 20 here and 160 here and 20 here. So I have still kept the deal of the setup. It's a parallelogram. Opposite angles are congruent and consecutive angles are supplementary. Totally a parallelogram. Can we make a conclusion that it's a rhombus, a rectangle, or a square? Well, hopefully we know that we can completely eliminate rectangle or square because these are not 90 degrees. Can we conclude that this is a rhombus? No, we cannot conclude that because we have no information about the side lengths. We have no side information. We cannot make that conclusion. Okay, so we have no side information. The answer is no. We can't conclude it. Can we conclude that it is? No. No, we can't. Okay, why? Because we have no information about the side lengths. Okay, so we're talking about that. All right, next example. Hopefully we know a lot about rhombuses, rectangles, and squares. Okay, here's a fun question. I like this one. Given WRST is a parallelogram and WS is congruent to RT, segment WS is congruent to segment RT, can we classify WRST? Let's explain. Now, what is going on? What is this telling us here? Is this giving us a side length? Are we talking about two congruent sides? What's happening here? So I love this question because what is this all about? Okay, do we know what is this referencing? Right? Are we talking about sides? Is this what it's saying? Are we talking about like side lengths being congruent? Is that what's happening here? And the answer is no. No, it's not. This is what we're giving. WRST. It is a parallelogram. So let's write this parallelogram, or at least draw a picture. It doesn't have to be, a crazy parallelogram. Let's just draw it. Now what we're going to do is label it. Labeling is going to be important. So let's label it. We're going to label it WRST. Now remember how that works with naming stuff. WRST. We have to keep it consecutive. WRST. It doesn't matter how you make it. WRST. WRST. Right? No matter how you have it, it's still WRST. Okay. So we have this part. Now we can look at this statement given. What is this telling us is congruent? Okay. It's saying WS, segment WS. Look at the diagram we drew. Segment WS is from here to here. That's a diagonal. And RT is from here to here. That's a diagonal. So these are diagonals, and we have to know that. Okay, we have to know that we're talking about congruent diagonals. And now that we know we're talking about congruent diagonals, we now know, blam, it is a rectangle, right? We can totally, if it's a parallelogram with congruent diagonals, we got a rectangle going on. So let's look at our choices, right? Is it choice A, a square? Because WS and RT are congruent diagonals. We don't know if it's a square because we don't know any information about side lengths. Okay, no side information. If we have no side info, we cannot conclude a square. Okay, is it a rhombus because congruent diagonals make a rhombus? No, a rhombus means 4 congruent sides. So it ain't that, right? Can we say it's a rectangle because WS and RT are congruent diagonals? So, well, yeah, that's true, right? This is what we've just established. So the correct answer in this case is C, but we have to know why. Okay. The important thing here is to label stuff. So I love questions like this because you have to take this extra step of knowing what's happening. Good things. All right, on to some algebra. So here's an example of a question. For what value of x is parallelogram ABCD a rhombus? Remember, do not overlook this. That gives us lots of neat information. But for what value is this going to be a rhombus? Well, what's happening here? We have these two angles, 4x plus 8 and 6x minus 2. They're tucked in right here. How would we know if it's a rhombus? We would know if it's a rhombus because the diagonals would then bisect opposite angles. So if the diagonal is bisecting an angle, we're good. Okay. So how would we know if it's a rhombus? If these two angles are congruent, we have a rhombus. So all we have to do now is set up our equation. So bisect means cut in half. Half means 2 equal parts. Okay. Bisect means cut in half. Half means 2 equal parts. And so we have our equation that we can solve. All right. So just like before, I am not going to show work. I have done a thing. Hopefully you see the thing that I have done is subtracted 4x from both sides. And again, I won't show work. I'm going to do a thing. Hopefully you see that the thing I've done is added 2 to both sides. And then lastly, you can now see that I have divided both sides by 2. So what value for x is this a rhombus? X would be equal to 5. Are we sure? Let's plug it in. All right. 4 times 5 is 20, 28. That would be a 28-degree measure angle. What about this? 5 times 6 is 30. 30 minus 2 is 28. 28, 28. We're all set. Totally bisected. X does, in fact, equal 5. Okay, so that's how we can do that. But we have to remember that diagonals bisect opposite angles. Here's another example where some more algebra is coming in. For what value of y, then, is parallelogram DEFG a rectangle? Now, I love this question for a couple reasons. The first reason is this. Parallelogram means the diagonals bisect each other. Okay, so diagonals bisect each other. Okay, so that means 5y plus 3 is here. That means this is also 5y plus 3. Just some helpful information. It's bisected. 7y minus 5 is here. That means 7y minus 5 is up here as well. That's what bisected means, right? But here's what's cool. How are we going to know if it's a rectangle? We know if it's a rectangle if both diagonals are congruent, right? If both diagonals are congruent. So if the entire diagonal, EG, is congruent to the entire diagonal, FD, and they're both being bisected because they're parallelograms, you know what we can claim? We can claim that 5y plus 3 is going to be equal to, I could write this number 7 a little bit better, 7y minus 5. So we can make that claim because it's a parallelogram, diagonals bisect each other, but it's a rectangle. We're trying to figure out what would it be for a rectangle. If the whole thing is congruent, then each half piece is congruent, right? So each half is congruent. So each bisected half, it would be congruent to each other. And the rest is algebra. So again, I'm not going to show work. I'm going to subtract 5y from both sides. Okay, that's what I have done. And now I'm going to add 5 ones to both sides, and then I will divide by 2. So my value for y would be 4. Now just in case, let's test this thing out. Okay, so what if I put a 4 here for y? 28 minus 5 is 23. I put a y here for 20 plus 3 is 23. Hey, all right, we're good. Okay, so we know the correct value of y is 4. All right. Fun times, right? Yay, algebra. Let's do a quick quiz, a couple quick quiz questions. I'm going to answer these as fast as I can, really, and help you. Oh my goodness, what's happening here? Small print, hard to read. Let's see if I can help clarify some stuff there. Can you conclude that the parallelogram is a rhombus, rectangular, square? What else is a valid conclusion? Explain. Parallelogram. What's happening here? We have an angle being bisected by a diagonal, and that tells us some stuff. Okay, so this tells us that diagonals bisecting, we have a rhombus. Okay, so we know that. Now we look at our answers. We know it's not A. We know it's not C. We have a B. It's rhombus. What's going on? Because the diagonal bisects a pair of opposite angles. Because the diagonal bisects true and true. Okay, so far so good. Also, by angle side angle and the converse of the isosceles triangle theorem, all 4 sides are congruent. Also, by side angle side and the converse of the equilateral theorem, all 4 sides are congruent. Whoa, that's so confusing. Which one is it? So remember, we have angle here, and a side here. This is angle, side, angle. Angle, side, angle. And 41, 41, that means we have isosceles triangle. 41 and 41 isosceles triangle. All 4 sides are congruent because of angle, side, angle, and isosceles triangle, which is right here. So the correct answer is, in fact, selection B. Right? This is a neat question, but that's what we can conclude. All right, last little bit, and we're done. So given the segments is shown, for what value of x is the figure a rectangle? Okay, so what's going on in a rectangle? Rectangle means we would have congruent diagonals. Okay, that means we would have congruent diagonals. If we're having congruent diagonals, if this is a parallelogram, the diagonals would bisect each other. So we could pick any two. Pick any 2 equations. So I'll pick x plus, well, not any 2 because it won't be proven there. Any 2 of this, either these 2 or these 2. So I will choose x plus 5 equaling 4x minus 16. If we pick any 2 to set equal, we know we'll have a rectangle. Okay, so I'm going to subtract x from both sides, and I'm going to add 16 to both sides, and I'm going to divide both sides by 3. X must equal 7. And just a quick mental check, because I'm not too crazy. If x is 7, 14 minus 2 is 12, right? If x is 7, 28 minus 16 is 12. If x is 7, 7 and 5 is 12. If x is 7, if x is 7, 21 minus 9. Yep, 12. All works. X is 7. And that's how that works. Okay? So hopefully that was doable. We've seen worse things. And that's it for our conditions for rhombuses, rectangles, and squares. enough practice for today, and then we'll get into trapezoids and kites next, and we'll have some fun. So see you guys later.